We are now ready for problem 22. And now we come to the last part of the class, which we started learning how to perform integration. Of course, this is an integral, so pretty straightforward. You just do each of these terms one at a time. Maybe let's do it up here. So 6x squared, you have the 6, and then you increase the exponent by 1. This is like the power rule. The new exponent goes on the bottom. 5x, increase the exponent by 1. The new exponent goes on the bottom. Plus 5x, and don't forget to add the constant or it will be counted wrong. So if we simplify this, this would be like 2x cubed minus 5/2 x squared plus 5x plus c. Here's the next one. I would like to use the power rule again, but I cannot quite yet because my exponent's in the denominator. But we can always rewrite that and change 1 over x to the 13th to x to the minus 13th. So now I can use my integration rule for powers. You add 1, and then you write the new denominator, put it at the bottom. Of course, you can't forget your constant. So if I convert this back to a positive exponent, negative 1 over 12 times x to the 12th plus c. Here's one that can be tricky. Just so you know, some students will try and when they try and apply the power rule, they end up with a 0 in the denominator, which you can't have. It's not how you do this. This is a special rule. The integral of 1 over x is simply the natural log of x. Now the x has to be in the absolute value signs plus your constant. So that's one of the special cases of integrals. Here's another one. E to the 5x, this is the natural exponential function. The rule for that is the 3 tags along. You simply rewrite the exponent, and then whatever is in front of the variable x goes in the denominator. So by the time, and of course the plus c, by the time you simplify it, you have 3/5 e to the 5x plus c. All right, so these are just basically knowing some of the basic rules of how to integrate. Here's an example. They give us the first derivative function and ask us to find the original function. And then they give us an initial condition. The reason they give us this That's going to be used toward the end of the problem. That'll help us determine the value of C. So basically, we're trying to find the function, which is just going to be the integral of the first derivative. The first derivative is 10x minus 7. So the integral of this is going to be 10x squared over 2 minus 7x plus c. Now we want to go ahead and find out what number c is equal to. And that's why they give us this. They say f of 8 equals 0. That means if we set x equal to 8, the function equals 0. So that's what I'm going to do right here. I'm going to replace x with 8. This is going to be 5 times 8 squared minus 7 times 8 plus c. And this whole thing, f of 8 equals 0. So 8 squared is 64. 64 times 5, I think is 320, but I want to be sure. That's correct. So 320 minus 56 plus c. So 320 minus 56 should be like 264. Yep. I'm going to solve for c, subtract 264 from both sides. So therefore the constant should equal negative 264. So now my function is going to be 5x squared minus 7x minus 264. All right. A little bit of a story problem. Concert promoter sells tickets as marginal profit function low. So this is called the marginal profit function. It's really a first derivative. This means that the rate of change, so they give you some more information. Find the total profit from the sale of the first 70 tickets, disregarding any fixed cost. So what they do is, in a sense, even though it's a story problem, you can tell this is like a first derivative. And what they're wanting to know is, or actually, they really want to know it for 70 tickets. So we're going to take the integral of the first derivative which is going to be 6x squared over 2 minus 1113x plus c Now, when I say this line about disregarding any fixed cost, I think that means that this constant is going to be 0. So basically, the profit is 3x squared minus 1113x. So if we want to know what it is, 70, it's 3 times 70 squared minus 1113 times 70. So this is definitely a calculator kind of problem. $70 squared times 3. I'm going to store that. Then 1113 times 70. It's negative. Negative 63,210. So basically, at 70 tickets, we're losing money. So they better sell more tickets or they're going to lose money. All right. So now one of the main uses of integration is to find the area under the curve. That's what we're going to now. They'll give us this function. We're not going to graph it. We don't need to graph it. But they want us to find the area under this curve when x starts at 1 and goes to 7. Area under the curve. And what they typically mean is area under the curve to the x-axis, right? So we're looking for this area. And when then the way you do that is you take the integral of your function it's going to be a definite integral. We're going to go from 1 to 7. Now this integral of 2 over x is going to be the natural log function. So it's going to be 2 natural log of x. And we're going to evaluate it from 1 to 7. And they ask for an exact answer. So as I work this out, I'm not going to use my calculator. So 2 natural log, put the 7 in first. Obviously by 7 is just 7 minus natural log of 1. Now natural log of 1, hopefully you know this, 0. So if we didn't mess up, hopefully the answer is 2 natural log 7. And that is correct. All right, here's another one. This is simply a definite integral where you're going to go, x is going to go from 3 to 4. We're going to evaluate this integral. Pretty straightforward. So integral of 4x cubed is 4x to the 4th over 4. Integral of 4 is just 4x. This whole thing is going to go from 3 to 4. So this is really just x to the 4th plus 4x. So I plug in first, plug in 4 for all my x's. 4 to the 4th plus 4 times 4. Subtract, now I plug in 3 to all my x's. 3 to the 4th plus 4 times 3. 4 and 4 is a pretty big number, I think. Not that big. 256 plus 16 minus 3 to the 4th, 9, 27, 81 plus 12. So this is 272 minus 93. If I did that in my head, I'm going to guess 172. I'm going to guess 181. I don't trust my head. See, 179. I was wrong. Hopefully that's correct. And that is. Now here's one where we're given two curves, two graphs, two functions, how you want to call it. I'm going to find the area between these two functions. Now, they don't give us what x is to go between, so we're going to assume that these intersect. We got to find the two values of x that intersect, and that's what we're going to use for our integral. So the first step is I have to find out where these graphs intersect. So I have to set them equal to each other and solve for x. So once again, we did this when we talked about this. I'm going to move everything to the right-hand side. So I'll have x squared minus 4x, subtract 3, and actually it cancels out. Makes it easy to factor. X minus 4. So when you solve this, you get x 0 and 4. So that means when I do my integral, it's going to start at 0 and going to go to 4. And what the integral is going to be, I'm not really worried about which of these is on top and bottom, because if it's a negative number, I just know to make the answer positive. So I'll just go ahead and say the area from 0 to 4 I'll start with this one just for fun. 3 minus 4x minus 3 minus x squared. Right, so I just took this function, this equation, minus this one. Now let me simplify it first before we take the integral. So I notice here a negative x squared. So it's going to be x squared. And then negative 4x. And then negative 3 and 3's cancel out. So this is my integral. X cubed over 3 minus 4x squared over 2. And it has to go from 0 to 4. Of course, 4 over 2 is just 2. So if I plug in 4 for my x's, I have 4 cubed over 3. So this is 2x squared. 2 times 4 squared. Oh, you plug in 0 for x, 0 for x. So really it's 4 times 4, it's 64 over 3, 1632. I get a common denominator, 64 over 3 minus 96 over 3. I think it's going to be minus 32 over 3, which I know I can't have a negative area. So hopefully, if I didn't mess up, it's just going to be 32 over 3. All right. Now, average value, right? Average value problems. You take the integral. Let's just do this. Here's the function. And we want the average value when x goes from 0 to 24. So what you do is you take the integral of the function, x squared plus x minus 12. And for your integral, you go from 0 to 24. But then you take that integral and you divide it by the difference of your starting value of x and your ending value of x. So it's going to be 24 minus 0. So you got this integral over this number. So really the main thing is now let's figure out this integral. So let's figure out the integral and then we'll come back and plug it in the number. So that integral is going to be x cubed over 3 plus x squared over 2 minus 12x. We're going to go from 0 to 24. Whoops, 0 to 24. Now the nice thing is the 0 part, they're all zeros, so nothing to subtract. So maybe it's just plugging in 24. So 24 cubed over 3 plus 24 squared over 2 minus 12 times 24. Now they want the answer as a fraction, so I can't really grab my calculator and do a decimal kind of thing. So this is going to get sort of messy. 24 cubed. Can't be a small number. $13,824. Wow. Plus 24 squared. This is going to be more of a problem of doing fractions than anything else. And then 12 times 24, 288. Common denominator is going to be 6. So this first one multiplied by 2 over 2. So 13,824 times 2. 27,648 over 6. Here multiplied by 3 over 3. 576 times 3. 1728. Multiply 288 by 6. 1728. Well, that's interesting. These two cancel out. 412. Actually, so I'm left with this right here, which is this. I wonder if this divided by 3. So this right here turns out equals a nice number. But don't forget, this was just the integral part of this whole problem. So now 4608, I wonder if it is a number. It is. Wow. Amazingly enough, that's actually the correct answer. So that's how to figure out average values. All right, only a few more problems left. Let's finish, because these are integrals, and these I believe are going to be called integration by substitution. So let me just do it the way I taught it. To me, that's pretty much the easiest way to do it. So normally what you do is, normally whatever's in parentheses, that's what you define u to be. So in this case, I'm going to say u is equal to 1 minus x to the fourth. Then I take the derivative of this little expression, du dx, 1 minus 4x cubed. And then normally I want to get dx by itself. Oh my, I didn't take the derivative correctly. That's crazy. Sorry. Derivative of 1 minus 4x cubed is just negative 4x cubed. So dx, negative 1 over 4x cubed times du. So what I do then, I go back with all this stuff. I need to substitute, and hopefully this integral with a bunch of x's ends up with all u's in it. Now to start with, I'm stuck with the x cubed, so I'll leave it there for now, but I hope it goes away. 1 minus x to the fourth is u, so this becomes u to the sixth. dx is minus 1 over 4 x cubed du. Now the good thing is you see the x cubed in the top, the x cubed in the bottom, those cancel out. So I've achieved my goal of, with the negative out front, of, actually I'm moving the negative 1/4 out front. And I have an integral with only u's, and I actually can solve that integral. I'll first make this u to the minus sixth. So then minus 1/4 u to the minus fifth over minus 5. So it's really 1 over 20 u to the fifth. Now I replace my u with what I started with, 1 minus x to the fourth. Let me just write it over here. So 1 over 20, 1 minus x to the fourth, all that raised to the fifth power plus c. Cross my fingers, and that is correct. All right, a couple more problems. Another integration by substitution. Whenever you have this exponential power, almost always you let u equal the exponent. So then I take my derivative. And I want to get dx by itself. Now, come over here, hopefully, once I substitute, I won't have any more x's, now I'll have u's, and I'll be able to integrate. Notice this is a definite integral, so at the end, I'm going to actually get a number for an answer. 6x to the fifth, I'm sort of stuck with for now. E to the x to the sixth, that's e to the u, and dx is 1 over 6x to the fifth times du. Actually, I shouldn't put this here now because these are for x, and I'm working with u now, so it's not really quite right to leave it there. But it's okay, we'll fix that later on. But I'm very happy that 6x to the fifth and 6x to the fifth cancels. So I ended up with e to the u du, which is one of the easiest integrals. E to the u plus c. Guess there's no plus c, it's just e to the u. Now let me switch from u back to x. So this is now going to be u is x to the sixth. And now I can put back in my 0 and 1. So I'm going to put in 1 for x, e 1 to the sixth, minus, now put in 0 for x, e to the 0 to the sixth. 1 to the sixth is 1, so it's just e. 0 to the sixth is 0, e to the 0 is 1. I believe the answer should be e minus 1. And the last problem, another integration by substitution. (34). Once again, usually let u equal what's in parentheses, du dx, 2x, solve for dx, 1 over 2x du. Try and substitute, switch from x's to u's. Got an x here, which I can't do anything about. X squared minus 16 is u, so this becomes u squared. Dx is 1 over 2x du. So this x and this x cancels out. I'm actually left with 1/2 u squared du. That's a pretty straightforward integral. U cubed over 3. Now let's substitute for u, x squared minus 16. Oh, let's make this 1/6, right? 2 times 3, 1/6. And then x squared minus 16. And we're going to go from 4 to 5. All right, now this math might be kind of messy, looks like, because let me pull the 1/6 way out. So plug in 5 for x. So 5 squared minus 16 to the third power minus, I was plug in 4 for x. 4 squared minus 16 to the third power. So this is 25 minus 16, which is 9. 16 minus 16, well, that's nice. So what is 9 cubed? Maybe 729. Now, no, I don't think 6 goes into that. No. 18. I think I can divide by 3 though. 729 divided by 3. 243. So I'm hoping the answer is 243 over 2. And that is correct. All right. So there's your review for the final exam.